Today I'm going to talk to you about the integration technique. And one method of integration by techniques is by use of the substitution method. So today I'm going to show you substitution method. It's used when an integral contains some function and its derivative. So for us to use a substitution method, we must have a function and its sum of the derivative. Then suppose f of u, capital F, is a function, then its derivative is the f of u. In substitution method, normally we use u to find the derivative and its derivative. Then it will be the integration of f of u multiplied by its antiderivative, which is the same as the du, is the same as the capital F, the function of f, then I plus the constant. For us to understand more about the substitution, I have these three examples that will help us to understand more. The first example is example number 1 is the integral of 3x minus 4 power 7 dx. Then you have been told to use of the substitution method to solve this. Don't worry, this is the easiest method of integral techniques. Then I write the solution. What I'm going to do, I say let this function, which is inside here, it will be 3x minus 4 to be u. Then u is the same as 3x minus 4. Then I find the derivative of the function u, which is the same as I find the derivative of this with respect to x. Hope we are together. I differentiate this one with respect to x. This one I will treat it as a constant. Then I'm going to find the derivative of this. I differentiate this. It will be 3dx. Because the power is 1, then if I multiply 1 multiplied by 3, I remain with 3. Because this dx is because I'm differentiating it with respect to x. Then I can divide here by 3, then I divide here by 3, meaning dx is the same as 1 over 3 of what? Of du. Having said that, then in my equation I'm going to substitute u in place of this, then dx in place of this. Then it will be this way: the integration of u raised to 7 multiplied by this du, which is the same as 1 over 3 du. Because this is a constant, I can place the other end to be 1 over 3 the integration of u raised to 7. If I do this, the integration du, this is the same as 1 over 3 multiplied by the integration of this one. I add 1, then I divide with both. If I add 1 here, it will be u raised to 7 plus 1 divided by 7 plus 1, then plus a constant c. This one is the same as 1 over 3 multiplied by u raised to 8 over 8, then plus a constant c. This one, if I do multiplication of this, is the same as 1 over 24 u raised to 8 plus c. But remember, our u is 3x minus 4. Then in place of u, I substitute. I just take u, then I substitute in place of u. A substitution method. It's the same as 1 all over 24 into 3x minus 4 raised to 8 plus c. And this is the answer. Very simple. That was my first example. Let me look for the second example. I'm sure you'll understand more. And the essence of mathematics, that concept does not come only once. You have to try and try until you get it. The second example is the integration of 2x all over 1 plus x squared dx. Then you have been told to solve this equation by use of the substitution method. We are just using the same procedure. It is very simple. Solution. What I'm going to do, I look for the polynomials. This is a polynomial. Then this function, I'll say let u be this function that is in the bottom, the denominator, which is 1 plus x squared. Let my u to be this one. Then the du, the derivative of u, it will be, if I differentiate this with respect to what? To dx. It will be very simple. This one, I multiply the other side, it will be 2x dx. Why dx? Because I'm differentiating it with respect to dx. Then, this one, 2x dx is the same as this. Then, I'm going to substitute in place of 2 dx, I substituted this one. Then in place of this, I substituted this. Then it will be the integral of 1 over u multiplied by du. This one, what I've done here, I've taken, in place of u, I've substituted this one. Then du, it is the same as 2x dx, this one. This one, if I can rewrite it, it's the same as 1 over x plus x squared multiplied by 2x dx. This is the same as this, what I'm going to do here. Then I do the integration of this. Remember, the integration of 1 over u is the same as the ln of what? Of u. Then I add a constant c. Having said that, in place of u, we know it is this one. Then I come and substitute here. It will be the ln of 1 plus x squared, then plus a constant c. And that is the answer. Very simple. The last example is we have given the integral of x, then exponential of x squared dx. You have been taught to by use of the integration techniques, which is substitution. This is also very simple. If you try more example that looks alike, you'll get this concept. Then this is the same as, I will take this x squared to be my u. Then I say let u be x squared. Then du, I find the derivative of this x. This is the same with respect to dx. It will be 2x dx. But in our equation here, we are having x dx, but here it is 2x dx. I want it to remain x dx as my equation. What I'm going to do next, I divide here by 2, then I divide here by 2. This one and this one will cancel. I'll remain with x dx is the same as a half of the du. Then I substitute. In the place of x squared, I substitute the value of u. Then in place of x dx, I substitute with a half du. Then it will be the integral of exponential of u multiplied by a half du. Because this is constant, it's the same as a half of integral e raised to u du. If I differentiate this, it is very simple. It will be a half multiplied by e raised to u plus a constant c. That is the integration. But in place of u, then I'm going to substitute with x squared. Then my final answer is a half e raised to x squared plus c. And that is our last example. So this method of integration does not come once. You have to get more examples that look familiar with this. Try to do it, and you'll get to understand. Thank you for watching.